Okay, well, thank you so much to all of you for calling in. A special thanks to eScience and to Jose for the incredible guidance and work over the winter quarter. I am a newly minted PhD from the Political Science Department at the University of Washington, and am currently a postdoc with political science and also computer science at University of Washington. So the project that I'm presenting today is part of that broader postdoc project that I'm working on. Now, are we still okay tech-wise? Everything's working?
Yep, everything's great.
All right, great. So this project analyzes archive data of government correspondence files during the United Kingdom's troubles in Northern Ireland. So since 1920, Northern Ireland has been formally part of the United Kingdom, and its local government has been led primarily by a Protestant majority that is loyal to the United Kingdom. But by 1971, the minority Roman Catholics living in Northern Ireland had experienced decades of political and social discrimination. And so in response, what they did was initiated civil rights protests for their rights, which yielded unrest and at times violence. Meanwhile, the predominantly Catholic Provisional Irish Republican Army, or the PIRA, and others initiated violent terrorist attacks as part of their campaign to liberate Northern Ireland from the United Kingdom. So this means that in August 1971, the government in Northern Ireland, with the backing of the United Kingdom, initiated internment without trial in order to contain the political upheaval and the terrorist violence. So they interned a total of around 1,800 Irish Catholic citizens without trial. Now, this is a really big deal because the right to a fair trial and to fair sentencing in advance of and before long-term or indefinite imprisonment is a bedrock of liberal democracies like the United Kingdom. So Northern Ireland's internment order violated this fundamental human right. Our broad research question seeks to ask, how do these liberal democracies justify those policies that violate the rights of targeted citizens? And this is a key political science question of our time, particularly as democracies all over the world, including the United States, point to either real or perceived national security threats in order to justify rights-based violations, and these rights-based violations which often target racial, religious, or ethnic minorities. To answer this question, we use recently declassified documents from the United Kingdom's government correspondence files to begin to tackle this broader question. And specifically, therefore, we're asking in this project, what were the British government's internal justifications for interning Irish Catholic citizens without trial? Now, the Incubator Project's objective was to, actually, it just occurred. Okay, is that better? The Incubator Project's objective was to explore whether we can use machine learning natural language processing methods to identify and to classify government justifications for violating rights in text, and specifically for justifying internment without trial. Now, the data we use are archives from the UK Prime Minister's security-related correspondence files between 1969 and 1973. So this includes letters and memos and telegrams, draft public statements, has a lot of handwritten edits, etc. Prior to the incubator, our team reviewed 7,000 pages of these archived government correspondence documents, which had been digitized, or which we contracted with a third party to digitize. And from there, I hand-coded and classified each incident of a justification for internment into 12 original justification categories. And then what we did was we reduced these categories to 6 categories for the purposes of our NLP analysis. Now, this yielded around 2,200 unique justification entries for internment, which we hand-coded at the sentence level in vivo, which is a qualitative coding software. In other words, this gives us what is effectively the universe ground truth in this particular data to begin to explore the possibility for either for both identifying government justifications in other government texts and more broadly for exploring the use of NLP methods on complex and idiosyncratic text like archive text. But first, what is a justification? So we treat it as an incident of a government official explaining or rationalizing internment. And what we see here on the screen is a telegram from the UK Prime Minister to US President Nixon, privately alerting him that they have initiated internment. And you can see here, the memo says, quote, "The latest series of acts of terrorism by the IRA and their recent declarations of their intention to continue and even escalate the campaign have made it essential to take this action." And here they're speaking about the action to initiate internment, however abhorrent, in order to prevent the undermining of economic and social stability in Northern Ireland. So this sentence received a few justification classifications, including the terrorism, what we call the terrorism justification. So we're using the idea that these people are perpetrating terrorism to justify internment without trial. Okay, so there are a variety of aspects of this data and other data we would apply this research to, which makes this task particularly challenging, including imperfect digitization, handwritten notes and edits, sentence carryover from one page to another, document duplication in whole or in part. In other words, we expect a lot of noise to complicate this NLP analysis. But today I want to highlight three things that Jose and I accomplished during the incubator, and then talk a little bit about some of the next steps for this project. First, we uploaded and integrated and analyzed our qualitatively coded material into Python to streamline and economize our analysis of the archive corpus. So this produced a couple of products. The first is that we concatenated material from 7,000 images into a complete archive corpus. We retrieved and managed each qualitatively coded justification entry into a justification corpus. We also generated data sets for other research tasks related to the project and plotted justification frequencies by category and over time. So you can see, maybe the top is cut off, but this plot roughly represents the occurrence of any justification in any category over time during the course of our data from 1970 to 1973. And internment, it's important to note, was initiated in the time period represented by file 0479. So this file right here, if you can see my cursor, which means that there was a spike and a considerable portion of the justifications that occurred in our text in advance of that initial policy. Okay. And then we can also look at the frequency of each justification category. And what you can see is that among the most frequently occurring categories are those based on terrorism, based on the legal authorization or the legal entitlement for internment. Here we call that legal procedure, and based on the emergency security situation. But I also want to point out that the political justification also occurs relatively frequently. That's right here if you can't read this tiny text. And that's a situation in which a government official would say that they need to initiate internment because their political base is demanding that, that the Irish Catholics be interned, which is sort of interesting in and of itself. And of course, we're also able to plot the frequencies of justifications per category over time. So the second thing that we did in the incubator was to explore training a machine learning approach, and specifically binary and multi-class text classification, in order to classify a specific justification entry into its appropriate category, given the presence and frequency of words in a sentence. So using this bag of words approach. Now, I want to point out here that we initially began with these 12 justification categories, which was derived from my original coding ontology schema. And then we tried a simple binary classification of the most prevalent categories to assess signals in the data. And this model performed quite well, actually, for classifying sentences, specifically for some of the most prevalent categories, the most prominent categories, with up to between 75 and 90% accuracy. So this suggests that there was some signal in the data for us to assess in a more sophisticated manner, and also sort of suggests that a more sophisticated manner would be needed because in some cases that's a little bit too high of accuracy. So next we further tightened those categories for classification text into 6 category schemes. And from here we assessed and tuned a final multi-class text classification model using these 6 classification categories. Now, the best performing machine learning classifier it turned out to be a logistic regression model. And after doing hyperparameter tuning, we concluded that the model performs best when it used stemmed words, when it approached using words as unigrams rather than bigrams or n-grams, when it removed English stop words, and when it removed words that occurred fewer than 10 times in the overall justification corpus. Now, interestingly, reweighting the term frequency vectors based on inverse document frequency didn't improve upon this particular model. Now, this model accuracy was accurate about 43% of the time, which is better than random, so better than if we were to randomly assign among 6 categories. And of course, some of the models some of the classification categories performed better than others, probably because of the idiosyncratic nature of one justification category rather than another. Let me see. And one of the values of this approach was that and this step was that it also provided really useful information to us about our own categories. So it helped us to gain substantive qualitative knowledge and understanding about our own classification schema. For example, this displays the confusion, this confusion matrix displays the confusion between a justification's actual assigned category and the category that models predict it would belong to. And we can see that at the bottom and the right hand, the axes is our terrorism justification. And what we can see is that the terrorism justifications were correctly classified about 30% of the time, but that about 23% of the time they were misclassified as a security justification. So this quadrant right here. Which actually makes a lot of sense from a substantive standpoint, because there's a lot of overlapping substantive meaning between these 2 categories in our analysis. So this tells us something about the proximity between these 2 categories as we proceed with our qualitative analysis. And so this is sort of useful for that component of our analysis as well. I don't have time to get into it here, but we were also able to examine the vocabulary words that were most positively and negatively associated with each category at the unigram and bigram levels. So this plot presents those most highly associated words at the binary classification level. Now, this bag of words machine learning approach was informative, but it doesn't take advantage of all of the information we have about our text. So recall that we have an entire corpus of archived material, of which only a fraction was flagged as a justification, and therefore only a fraction was used in our analysis thus far. So we turned to a shallow convolutional neural network approach with a single hidden layer to iteratively train and update a model for predicting a justification entries classification. And among other benefits to this approach, it allows us to use word embeddings. So I'm sure the vast majority of you on this call know, but a word embedding is a sort of semantic and syntactic representation of a given word. And we can use this as part of the deep learning process to help train the model. Now, others have demonstrated that using pre-trained word embeddings can help in NLP classification tasks. So we decided to explore this route. Now we have a few options. First, we could build a neural network without any word embeddings, so a baseline model. Or we could use pre-trained word embeddings, say from Google. And I should note that we did implement both of these approaches, but I'm not going to talk about that or present that today for timing purposes. However, we believe that there are certain nuances and meaning in these government documents, and specifically nuances related to the time that they were written, the topic that they were talking about, idiosyncratic words related to security, the geographic location, i.e. specifically developed by British English-speaking government officials, and that all of these nuances will be useful in the classification task. So we developed word embeddings based on our complete archive corpus, which provides valuable semantic and syntactic information about the words that appear in our justifications. So once we develop these word embeddings, I'm going to go back. Once we develop these word embeddings, we then are able to embed them within our CNN to predict justification classifications. Now, given the nature of our data, this was always going to be a challenging task. We've got a relatively small amount of text data to work with and to train our word embeddings. And the errors, there are a number of errors present in our data, which I covered earlier. And all of this is going to make this development of word embeddings challenging. However, we do have some reasons to believe that the embeddings that developed were actually quite meaningful and informative. So this figure, again, I'll talk through it in case it's not legible on your screens, but this figure plots the words that are most similar in our data word embeddings to 6 important words within our corpus. And so 6 important words relevant to our particular research question. So let's look at the word Faulkner, for example. These are the orange dots on the plots. You have Faulkner right here. Brian Faulkner was the Prime Minister of Northern Ireland during this time period. And other words that are semantically similar to Faulkner should include other policymakers and policymaking processes. And indeed, we see that several other key government officials appear as those words most similar to Faulkner. So we have Prime Minister Lynch, we have Whitelaw, Cosgrave, Hume, Wilson. These are all politicians that are relevant to this particular conflict. And so this suggests that there is some meaningful and useful information that is represented in these word embeddings. And from here, we incorporate these corpus-based word embeddings into our neural network model to see how it aids our classification task. Now, the answer right now is that the model does not perform particularly well. So our preliminary model is overfitted to the training data, the blue line, and only achieves about a 30% accuracy when classifying our testing data, the orange line. Now, as I know you are all aware, this is not an entirely surprising conclusion at this preliminary stage of the analysis. And we have identified a few steps that we can sort of build on from here to continue to advance the project. So the first step is that we will explore hyperparameter tuning to address this overfitting of our training data. So things like dropout or batch normalization. The second thing is that we will explore using word embeddings based on our archive data to augment and supplement rather than to replace the Google word embeddings in order to provide more information about the words to hopefully improve the model's accuracy. third, we hope to use our existing neural network skeleton to train a classifier to identify the presence or absence of any justification from any category within the entire archive corpus. And finally, doing this will hopefully lay the groundwork for us to begin adapting and applying this approach to other government texts, which may include a justification for internment or another human rights violation. And I really look forward to continuing to work on these steps in the process with Jose at eScience, and also with Noah Smith and Emily Gade, who are the PIs on this broader project. So thank you for your time, and I look forward to hearing your comments and feedback.
Hi, thanks, Sarah. I had a quick question.
Yes.
So you mentioned that you didn't have time to talk about it, so maybe I'll give you a little time to talk about it. But you did some work to look at the words that were most positively and most negatively associated with each of the 12 justifications.
Right.
I was wondering, first of all, I'd be interested to hear more about that, and then we sort of if there were any insights that came from, but also did that inform any of the next steps? Like, were there words that you then discovered in that process that allowed you to further refine the activities that you were doing?
Sure, that's a great question. It informed the further process in, I think, at least 3 ways. So the first is that, as I mentioned, as we were moving from the 12 categories to the 6 categories for our machine learning analysis, we were able to make judgment calls about how to kind of recategorize and how to shuffle those based on the words that we saw that occurred within those plots. So in other words, and more specifically, once we had gotten those, we tried a couple of different ways to recategorize. And when I'm talking about recategorize, I'm taking those 12 and making it 6. So we're not recoding anything, but we're just lumping those categories together in different ways. And we tried one way first, and then looked at those words that were most and least associated with the categories. And the first time we did it, it didn't work, right? We looked at the substantive output, and those weren't in line with what we thought that those broader categories were capturing. And so we had to adopt a different kind of logic to recategorizing those justifications based on that output that looked, just from a qualitative and substantive standpoint, much more representative of the concepts we were looking for. So that's the first. Is it answering your question, Sarah?
Yeah, definitely.
Yeah. Okay. So that's the first way that informed it. The second is that we actually are going to be engaging in a process from a qualitative standpoint of recoding some of the justification categories, because these categories were identified and developed deductively before we sat down and started coding those documents. And as we were doing that, different kind of themes emerged, as always happens with qualitative work, that you don't really anticipate and don't expect. And so there's a couple of categories that we need to sort of parse out and divide and reconfigure from a qualitative standpoint. And in that case, using these top occurring words is incredibly informative for us to sort of understand what are some of the discrete and maybe not necessarily related concepts that are getting lumped together in a given justification at this point. And then the third way that we're using it is, it's just been, we're starting to write up some of our preliminary results and analyses, and it's just been incredibly informative to be able to say, not just these are the words that occur most frequently, but these are the words that are most important in categorizing and distinguishing among these distinguished or these unique categories. So those are sort of 3 ways in which that's been a really useful tool to aid the multi-method analysis process that we're engaging in.
Great, thank you, Sarah.
Yeah.
It looks like we have a question from Rhodes. Michael, would you like to unmute yourself and go ahead?
Yeah, hi, Mike here. Just curious, can you talk more about how you selected your training data and why certain documents maybe over others?
Sure. So this is what kind of distinguishes this project from a lot of machine learning projects. We trained the entire corpus of data that we have. So we effectively have hand-coded the entire corpus of data that we're looking at. And so when we did that, we just randomly selected and randomly divided what had already been hand-coded into training and testing data. And the idea was that this was really the sort of first step exploratory process in order to figure out how we can use these methods more broadly, and what are like the promises and pitfalls of using these methods on something as idiosyncratic as archive-based text and government-issued statements. Does that answer your question?
Yeah, thank you.
Yeah.
We have time for another question. Andrew Bennett.
Hey, thanks for the talk. It was really interesting subject matter. But I was curious, you were using a convolutional network. Is there a reason you use that instead of some sort of recurrent neural network?
That's a great question. I am going to. There's a variety of reasons we did. I'm not able to answer with a lot of detail right now why we made those decisions. I don't know if Jose wants to jump in.
I can.
Yeah.
Yeah, I think there's a paper that came out, I think it was a couple of years ago, but essentially our tests, we're not trying to classify a whole document. We're essentially doing sentence classification, so like short text in a sense. And convolutional neural networks have been shown to do well with short text type of classification tasks. And so we decided to kind of try it out with that. And again, I think this is like still the beginning of this. Ultimately, I think what we have in our hands here is like a multi-label classification task, not like these sentences, for example, might have more than one code associated with them. And so we're just kind of going through the early stages of like, let's explore your data, particularly because the way the data was coded was for a qualitative research task. And so we're trying to kind of see if we can turn it into a machine learning classification task.
Thanks, Jose. That was much more articulate than I would have been able to do at this moment.
Cool, thank you.
Michael, do you have more questions?
Yeah, just a quick follow-up. So do you plan to use this in other contexts for like other nations that have text regarding rights violations or anything? Is that kind of the goal to use on other contexts?
Yeah, that is the broad goal. We're not entirely sure how or what that will look like, but in theory, yeah, that's one of the main questions that's motivating this research. So if you have any suggestions about, I mean, we've been kicking around a variety of cases that we would potentially look at, but haven't sort of honed in on what that research design will look like.
I just have a follow-up on that. Like, are data sets like this hard to come by? You kind of hinted at that at the beginning.
Yeah, that's one of the biggest issues that we would have for extending this in the future, and that is that this data set is one of the only that we're familiar with that gives what could be considered a snapshot of a universe of internal conversations about how to justify these decisions. We would potentially have to jettison that commitment to those internal statements and look more at government's more public presentations of their justifications in the future, often because, you know, governments typically don't release this information for years and years and years until after it has been generated. So we're like, that's one of the things that we'd have to contend with, is whether we would then extend and maybe look at Twitter data or something like that that would be public facing rather than internal. But that's the other reason why we really wanted to start with this case study, because it provides us a grounding understanding of what this looks like behind the scenes.
Is there somewhere where I can share the link for that paper that I mentioned on Zoom? I guess
I can send it to the group. Yeah,
I have it on my. I already have it copied. I just don't have a chat thingy, but it's okay. We'll send it to Dave.
Yes, we can make sure we send it out with the list. Do you have it up on your screen right now, Jose?
let's see. What is
What's that? Mute.
I have it copied. I have the link handy, and I can pull up the paper, but I just wanted to put the link to the paper somewhere.
We can send it out. That's awesome. Or we can actually add it onto the webpage. So if you're looking for more information about these talks, yes.
Here what we'll also do is we'll upload the GitHub repo and have that as a link in the notes for the GitHub repo. It's another place someone.
That's fantastic. So we can put those links up on the webpage for the community seminar and make sure that they get out to folks. So thank you, Sarah. I want to thank you, Ariane. These were great talks, and round of applause. So we'll be back here next week. And Sarah, do you have anything to add? I think next week we are April Craig and Rose Wade will also be sharing their outcomes from the incubator. So I look forward to seeing you all then.